Here's a scenario where device A needs to send a packet to device K. Device K is not part of this network, so its address is not listed in any bridge's source address table. This means that when a bridge receives the packet, it's considered an unknown destination address and floods the packet. Well, let's see what happens if spanning tree controls are not in place. Device A generates a packet destined for device K. Bridge XX receives the packet. Bridge XX examines the packet and its SAT and determines there is no listing for device K, so the packet must be flooded out all ports. The bridge then transmits the packet out ports 2, 3, and 4. It doesn't send it out port 1 because that's the port the packet was received on, and bridges don't send packets out the port they were received. The packet is now received by bridge Y. Y also determines it needs to flood the packet. The packet is sent out ports 2 and 3. At the same time that bridge Y receives the packet, so did bridge Z. Z also decides to flood the packet, and it's forwarded out its ports 2 and 3. At this point, the single packet originated by device A has now become 7 packets traveling around the network. 7 packets doesn't seem so bad. However, we've just started. When XX and Z retransmitted the packet, both bridges forwarded the packets back to the original bridge and to each other. And, since no bridge has been able to identify where device K is located, this flooding process continues indefinitely. Each bridge receives copies of the packet over and over, and since the location of the destination address is unknown, the bridges just keep flooding and flooding. Eventually, the only packets on the network are copies of the original packet that may have been replicated thousands and thousands of times. This is called a broadcast storm, and it can disable any network. This example illustrates what happens in a network with only 3 bridges, each with no more than 4 ports. But what happens in a network with scores of bridges and hundreds of ports per bridge? I think you can start to see the problem. The problem is that the bridge replicates and floods packets without considering where they originated. And because of multiple network paths, the problem gets worse and worse. In spanning tree terminology, multiple bridges connected by multiple paths is called a loop. This is because, as seen in the last scenario, we had packets endlessly looping around the network. So how do we resolve this problem? The answer is the subject of this lesson, spanning tree.